my name is Samir Khan, and I'm part of the product management team here at MapleSoft. My role is to speak to people and to help them understand our tools, technologies, and services, and take your feedback and put it back into the product development process. We're going to spend some time looking at MapleFlow. I'm going to tread a fine line between a straight product demo and a training course that you can participate in. Of course, this won't have the same depth as a proper training course where I spend a whole day with a team of people and help them to understand the minutiae of a product, the syntax, the detail. But we will hopefully give you enough skills so that you're dangerous with MapleFlow. So as Rochelle said, you should have received an evaluation license of MapleFlow, or you may already have purchased MapleFlow. The latest version is MapleFlow 2021.2, and that's the version that we're going to be working with. On screen, you should see MapleFlow started up. So the philosophy of this event is that I'm going to show you stuff on screen, and hopefully I'll give you enough time, enough flexibility to follow on with what I'm doing. We'll be working with complete applications, we'll be doing stuff from scratch, and we'll also be looking at some of the in-product resources as well. So let's get started with this, and hopefully let's have fun. I do think sessions like this are fun, and I do enjoy giving them. So on screen, you see MapleFlow. This is the home screen for MapleFlow, the start page. You see three buttons: one to create a new canvas, one to link, one to a series of built-in tutorials, and another button which goes to an application gallery. I'd like everyone to start off by clicking on the application gallery button. And that should load this up. So I think it's important to give people content and resources that they can start using straight away. There's nothing more daunting than a blank piece of paper when it comes to learning an engineering product like MapleFlow. And the application gallery is our attempt to give you meaningful resources, applications that you can work with straight away. You might just want to change a few parameters, update a few results, or you might want to copy and paste equations into a new worksheet. There's a lot here. Now, there are applications across a number of engineering and scientific disciplines. The application gallery will be a growing resource, and in successive versions, we'll add more and more content. We have resources across aerospace engineering, chemical engineering, chemistry, electrical engineering, hydraulics, mechanical, signal processing, and more. Some other sections have a deeper layer. So if I click on the civil and structural engineering section, that drills down to more applications across several subdisciplines of civil engineering: structural, reinforced concrete, timber, and there's some other stuff there as well. By the way, I'm using the mouse wheel on my mouse to scroll up and down the canvas. Let's start off by loading a complete canvas, and I'm going to pick one at random. Let's pick this one: crack width and doubly reinforced concrete beam. And this takes you to an actual MapleFlow application. So let's look at this and let's talk about some of the concepts we see on screen. At the top, we have a header graphic, a title, a description, and a diagram of a problem that we're solving. The diagram was simply imported from another application. If I scroll down, I see text, and these things here on the right-hand side are parameter definitions. They have units associated with them. So my yield stress has units of pascals. Dimensions have units of millimeters. If I scroll down further with my mouse wheel, I see equations in natural math notation. So things with overline division, superscripts of powers, proper Greek letters. And if I scroll down to the very bottom, I see the result of my application, which apparently is a crack width. Now, everything you see is in a container. I can take text, move it about on screen. I can take this parameter definition, move it about on screen. In fact, I can create containers which contain math or text or images at any point. So if I just click there and do something as simple as 1 + 1, followed by equals and enter, you might want to try that as well. I've created a math container. Now, this result has a unit associated with it. I can rescale the result to another unit by mousing over to the right-hand side and clicking on these double arrows here on the top left-hand corner, on the top right-hand corner. That pins open what we call the context panel. So now my focus is in this result, and I've expanded the context panel, and this allows me to rescale the unit to something else. So let's say I wanted to rescale this to inches. I can pick from a series of predefined units in here. So that's in inches, or I can type in a custom unit in here as well. Let's add in some numeric formatting as well. Let's change that to a scientific format. Later on, we'll learn how to actually define parameters with units. Now, a MapleFlow worksheet updates automatically when you change any parameter values. So if I look at this equation, it depends on the values of K2, K4. If I actually go up to this definition of K2 and I change it, that change cascades down the length of my MapleFlow canvas, and you might have seen that result change automatically. Let's do that again with K4. There we go. All the dependent quantities, results, any plots update automatically when I change a parameter value. If I go to the View menu and select Print Extents, that delineates the bounds of my chosen page size. I think I'm currently set up to use, if I go to the File Page Setup menu, a letter size page with these margins. I could change that. But this is what I'll see when I export this MapleFlow canvas to a PDF. You can see I have some math containers that cross over the right-hand page boundary. What I could do is adjust font sizes, move math containers into position so that everything fits neatly onto a page. And if I go to File Print Preview, this is what you'll see when you export this to a PDF. It's a faithful reproduction of the original MapleFlow canvas. Let's close that down. So we've discussed some basic terminology. We've looked at a complete MapleFlow canvas. Let's go back to the start page. If you click on this button, Tutorial, this takes you to a number of built-in tutorials, which are short and to the point, and they take you step by step through some basic concepts, how to navigate around the canvas, how to enter math. So if I click on this one, this is a tutorial that tells you how precisely you can enter, edit, and create equations, what keystrokes to use, and how to enter equations like this. We're not going to explicitly go through all of these tutorials. I may touch on a few of them. But for now, what I'd like to do is for everyone to go back to the start page. So you can see that MapleFlow is a tabbed interface. So as you open up more application, the Canvas tabs are displayed at the very top. So if I go to the Start tab, click on New Canvas, and this is what you see when you start a new MapleFlow canvas. If I click on this arrow on the left-hand side, this displays a series of palettes. We'll look at these later. So the blue cross you see on screen is what we know, what we call the grid cursor. I can move the grid cursor just by left clicking anywhere on my canvas, or what I can do is use the arrow keys on my keyboard to move the grid cursor about. Containers are created at the location of the grid cursor. So at this point, if I type in 1 + 1 followed by equals and enter, that creates a math container. I can move this grid cursor down and create another math container. So one thing you have to be careful with is that the equal sign to evaluate a math container has to be on the very right-hand side of your equation. So with the arrow keys, you can move the editing cursor to the right-hand side of the math container. At this point, you can press equals followed by enter. So we have a couple of math containers on screen, and we can move them about. So if I take my mouse and I left click on this math container, I can shift it about on my canvas, like so. There's another way of actually moving math containers about on screen. And this is the method I use. It's a keyboard shortcut. So if I take the editing cursor and move it into this math container, so all I've done is navigate the grid cursor into this math container. This math container now has focus, it's active. At this point, if I hold down the Control key on my keyboard, I can use the arrow keys on my keyboard to move this about. Now, there is an underlying grid in MapleFlow. If I go click on this button, this turns the grid on. And basically, the math container snaps to the grid. So if I move this container about, you can see that it's snapping to the grid. Let's turn the canvas off, the grid off. So far, I've just created two very simple math containers. I can also create text containers. So if I just move the grid cursor to a blank part of the canvas, now to start an empty math container, I just hit the spacebar. That just creates an empty math container. And at this point, I can start typing text. Let's create another one. Now, you can also format text as well. There's a formatting toolbar at the very top. So if I just triple click on all of this text, it gets highlighted. So that was a triple click just to select all of the text in the text container. I can go up to this toolbar and edit my text, change fonts, underline the text, change the color, and so on. I can also apply different styles to this text as well. So we have a number of predefined styles here. So I'm just going to select the title style for this text, and you can see that it looks different. Let's move that up there. You can also create image containers simply by importing an image. So if I already have an image on my computer, so if I go to the insert menu and select image, that's insert image, I can browse to select the container, an image file that's already on my computer. So you can experiment with importing any image that you have on your computer. So here I have 3 types of containers: math, text, and images. So far, it's very simple. I can also define parameters that I can use in my calculations. So let's say that I want to define a parameter called x. Actually, so all I do is type in x, followed by colon equals, then the value I want to assign to x. And at any point below that definition, I can use x in my calculations. So x plus 3, 2 times x. By the way, I'm using standard keyboard shortcuts. So for the multiplication, it's simply the asterisk, that's Shift 8 on my keyboard. There are lots of neat shortcuts for typing in more complex math in MapleFlow. If you expand the expressions palette, this has a number of mathematical templates that you can just insert into MapleFlow. So for example, if I want a square root, all I do is insert the square root template, fill in the placeholder, and evaluate the math container. There's another neat way I can enter in a square root. If I just type in sqrt, then initiate command completion with escape or control space on my keyboard, that brings up the command completion menu. I can turn sqrt into a typeset square root symbol simply by selecting the first option. Some completions may have more than one option. They might have 10. They might have 20, but for sqrt, there's just these options. So I'm just going to select the first entry and press enter. At this point, I can simply fill in the placeholder and evaluate that math container. Now, there is a flow of control in MapleFlow. MapleFlow evaluates math containers from left to right, top to bottom. So if I define another parameter, let's call it y, then evaluate x plus y. Well, x plus y knows what the value of y is, because I've defined it here. But if I take this evaluation and move it to this point, well, this math container doesn't know what the value of y is anymore. So it's left as what we call an unassigned name. Move it back down. There we go. Now, there are also a library of built-in functions and commands in MapleFlow. This, for example, is a built-in function, sine. That's all it is. Sine of 30. Well, that's 30 radians. So MapleFlow is built on top of the Maple programming language. So the Maple programming language is a vast collection of math routines, functions, procedures that cover virtually every corner of engineering math. So there are tools there for matrix computation, statistics, probability, equation solving, and much more. We're not going to cover the entirety of the Maple programming language. That's available in our online help. But we will introduce a few common functions. Now, a very common function is fsolve. Fsolve is a numeric equation solver. So, for example, if z plus log z is equal to 3, then z is about 2.2. That's a very simple example of fsolve. It's capable of much more. There's a level of detail that we can go into about the syntax of fsolve, the various options, but we're not going to touch that in this webinar. There are many neat utilities in the Maple programming language, and as you grow more familiar with MapleFlow and the Maple programming language, you'll learn that there are tools and utilities for many, many different things. A common thing that many people want to do is extract thermodynamic data or physical data or transport properties for fluids and solids. MapleFlow and the Maple programming language actually has a full computable database of thermodynamic and thermophysical data. So you don't have to type this in. I'll just show you what this is. So for example, if I want the density of water at a temperature of, let's say, 300 Kelvin, pressure of 1 atmosphere, I can do that. And the result is returned with the units associated with this as well. Now, units are a core concept in MapleFlow. There are several different ways you can assign units and use units in your computations. The easiest way is just to use the units palettes. So if I expand the units palette, I can pick a dimension, length, linear frequency, momentum, mass. What I can then do is define a parameter, let's say m1, colon equals 3.4. And if I want to assign a mask to it, all I do is make sure the editing cursor is on the right-hand side of the number, the 3.4, and then click the dimension. And that inserts this on screen. So the blue box that you see on screen is actually a units placeholder. That signifies that your focus is currently on the unit associated with this parameter. If I use the left arrow key to move the editing cursor out of the units placeholder, that blue box disappears. If I move the editing cursor back into the unit, the blue box appears. It's just a quick visual indicator that you're currently inside a units placeholder. Another way of assigning a unit is just to use the unit function. So I'm going to create another parameter and give it a mass of about 4.5 grams. However, what I do most often is that I simply use a keyboard shortcut to place a units placeholder on screen. So if I do something like this, if I want to insert an empty placeholder, an empty units placeholder in my canvas, all I do is hold down the Control key, the Shift key, and press U. That's Control Shift U, and that places this on screen. It's a units placeholder that's currently highlighted. All I do now is type in my chosen unit into this. So for example, LB for pounds. Now, once I've defined all my units, I can add all my parameters, I can add them all together and get a result in kilograms. So the results of equations with calculations with units are automatically given in SI units. So kilograms, meters, pascals. But if I want to rescale this to another unit, let's say pounds or grams or something else, I can just click inside the result and pick my chosen unit from the context panel on the right hand side. And here I'm just going to pick let's say milligrams. So I've introduced you to some basic concepts. We're going to go into some of the syntax and the terminology of MapleFlow in greater detail. For this, we're going to go back to the start page and click on tutorial. This brings up the list of tutorials. We're not going to do the first few tutorials. We've already covered those basic concepts, but we're going to click on this thing, basic math concepts. So if I click on the button on the left-hand side of that, that takes us into this. Now, to be truly dangerous with MapleFlow and to use it for non-trivial problems, you need to understand some of the terminology, some of the syntax involved. And that's what we're going to cover. So if you just type in something like 2 times x or y squared or something else like that, Those are known as expressions. An expression can be simple, like this, or they can be far more complicated. Something like that. Another important concept are expression sequences. That's simply a number of expressions in a single math container separated by commas. So this is an expression sequence with 3 elements. Now, when you define a parameter, that parameter has to be given a name. So you can define a parameter. You give it a name of foo and a value of 4.5. But the thing on the left-hand side, the foo, is known as a name. Names can have subscripts. You can enter a subscript using the expressions palette here. It's this thing here. Or what I usually do, I just use a keyboard shortcut to enter in a subscript. So if you just type in the main part of the name and then type in 2 subscripts, so 1 subscript, sorry, and then you type in 2 underscores, so that's my first underscore, followed by my second underscore. As soon as I enter in the second underscore, those 2 underscores are turned into a subscript, and I can simply type in the subscript part of my name. So as we've already seen, we can assign numeric values to names. But assignments can be a bit more complicated. In the world of the Maple programming language and MapleFlow, something like this math container is known as an equation. An equation has a left-hand side. In this instance, it's x plus y. It has a right-hand side. In this instance, it's z plus 6. And they're both separated by an equal sign. We're simply saying that x plus y is equal to z plus 6. So this comes up a lot in more advanced MapleFlow functionality. We may not get to this, but it's important that you know what this is called. Let's scroll down and look at this. So you've already seen that MapleFlow has built-in functions. So sine, cos, tan. There are many, many built-in functions. You can also define your own functions as well. There are a number of steps involved in defining a function. So you give the function a name, followed by colon equals. The function has to have a parameter. Let's call that parameter y, followed by an arrow symbol. We can create an arrow symbol simply with a hyphen and a greater than sign. So I've simply typed in a hyphen or a minus, followed by a greater than on my keyboard, and I automatically get that arrow. And then I simply have the body of the function. So f of y is equal to y squared plus 4. So if I want to evaluate that, I give that function an argument followed by equals, enter. Now functions can have many parameters, and you group together parameters with brackets, just like so. So that's the left bracket followed by the parameters separated by commas, followed by a right bracket. So at this point, what I'd like to do is actually start putting together some of the concepts that we've learned, how we can assign and use parameters, units, how we use functions, entering text to solve the problem. So let's go back to our start page and let's click on New Canvas. Now, because of my academic training, I always like fluid flow problems, so that's what we'll do. That may not be relevant to the work that you do, but the concepts will be. The underlying concepts of using MapleFlow will be relevant. So I'm going to start off by defining a few parameters. Now, the way most people work when they use engineering tools like MapleFlow, or tools similar to it, is that they're a bit haphazard. They might have a vague idea of where they want to end up and perhaps an even vaguer idea of where to start. And they might actually start off somewhere in the middle. So for example, you might want to balance a pressure drop against the pipe roughness to calculate fluid flow or flow velocity. And you might know that the pressure drop is defined by this equation. Delta P, I type in the delta just by entering delta with a capital D, then pressing the escape key on my keyboard. That changes it into a Greek letter, capital delta, equals the friction factor times the length of a pipe divided by its diameter multiplied by the density, rho. If I want a Greek letter rho, all I simply do is type in rho, RHO, then press escape on my keyboard. That brings up the command completion menu. And I think I want the first entry. So I simply select that, divided by 2 times v squared. So, and that's where I might want to start off, somewhere in the middle. And I might start off by typing in some text. Let's say that's the pressure drop. So then I have this equation. I have a number of parameters in that equation. So things like delta P, F, L, the diameter, rho. And I might want to assign those values that I know some values. So for example, I might know that the length of the pipe is equal to 33 meters. So let's type in 33, Control-Shift-U, M. I might know that the diameter of the pipe is about 7 centimeters, let's say 7.5, Control-Shift-U, CM. And there's that parameter F there. I know that's the pipe roughness. Sorry, that's the friction factor. I think that friction factor is defined by a correlation. So I know that's governed by an equation, not a simple parameter definition. So might type that in here. So I might say that the friction is equal to a standard correlation that I get from an engineering textbook. So I'm typing this in from memory, so I might get this wrong. So that might be my friction factor, which is an equation in which F is implicit. You can't explicitly rearrange this equation to give you F. So I enter that in as an equation. Might go back up to the top. Let's type in the value for epsilon. I think that's a fairly typical value for epsilon. And I might already know the value of the pressure drop, the delta P. So as you can see, I'm being pretty haphazard about this. I don't have a grand plan. I don't have all of the computational steps planned out in DCell. I'm just making up things as I go along. I think I also need to extract values for the density. And you know what? I think I'm going to use the function I told you before. So if I just type in thermo and then I press Control space on my keyboard, that completes that command. Now, thermophysical data is actually a package of commands. There's about 100, 120 packages in MapleFlow covering various niches of mathematical functionality. So if I type in thermophysical data followed by colon equals, then I hit Control space again, that brings up the command completion menu. And I know I want the property command. I know there's a syntax and a structure to the property command. You can look that up in the Maple Programming online help. So I know I want the density of, let's say, water at a temperature of, let's say, 300 Kelvin and a pressure of 1 atmosphere. Let's see what that's given us. So if I evaluate rho, it's telling me that the density of water is about 996 kilograms per meter cubed at the parameter values, the states I've chosen, at this temperature and this pressure. I know later on I'll also need the viscosity of water. So let's use the thermophysical data package to extract the viscosity of water. And those same parameter values. And let's see what it's given us. There we go. So I've got a number of math containers on screen, and at this point I might want to start placing some structure in a document. You can actually group math containers together in a section. So if I drag a selection box around all of these containers, so all I've done is simply click and drag a selection box around all of these containers. If I go to the insert menu and select section, I get this. So it looks like I have two horizontal black lines covering the math containers that I've selected, and there's an empty text container there. That's the title for my section. So I'm going to give my section, my group of containers, a title. Let's call it parameters. Now, sections are a really neat way of providing structure to your document. You can expand and contract them, just like so, just by clicking on the plus minus symbol. You can also change the appearance and the look and feel of these section lines by going to the Format menu and selecting Section Style. So there's a number of options there which allow you to change the look and feel of the section lines. You can also suppress the display entirely as well. You can expand and collapse the section just with the plus minus sign, or if you just double click on the top section line, the section also expands and contracts. Just going to take these parameters and capture those in a section. All right, so I think I need to enter another equation into this section. I don't have enough room here, so I'm just going to position my grid cursor somewhere between these two equations and press enter a few times. So enter on a blank part of the canvas just moves everything below that down. Conversely, I can also press delete on my keyboard to delete white space. So enter and delete, create and remove white space. So let's create another method container that contains one more equation. Again, I'm doing this from memory, so please forgive me if it all goes wrong. Right, so it looks like I have 3 equations. I think there are 3 unknowns. There's F, there's V, and there's REY. 3 equations and 3 unknowns, as far as I can see. And if I've done everything correctly, which isn't guaranteed, I should be able to solve these equations. So what I'm going to do is use this function, fsolve, to solve my equations. Now I have a group of equations that I want to solve collectively, and I'm going to collect those equations together in what's known as a set. So a set is delineated by braces, curly brackets. So I've just typed in a left curly bracket and a right curly bracket, and within those curly brackets, I'm just going to type in the names of my equations. So I know my equations are PD, Reynolds, and friction. And I'm going to specify initial values for the solvers. So I'm going to guess that V is about 0.1 meters per second. That's a velocity. I'm going to guess that F is about 0.001, and I'm going to guess that REY is about 1000. I think that's about the right value. So if I evaluate this, looks like I haven't done everything right. I probably made a mistake in one of the equations. So at this point, what I would typically do is go back to my equations, go back to my parameter values, and try to find out where I made the error. So I'm not going to try to hunt down the error while in the middle of this presentation. But if I've done everything, if I did get everything correctly, these equations, this set of equations would result, give me a solution.